Okay, so chapter 13 of C1, circles. What I want you to do first of all, and I know some of you may have looked at this in AdMaths, but that's nowhere near all of you. And if you have, can we not sort of let the secret out the bag, so to speak, to start with? I want you to look at this equation here in a minute, and I want you to consider values of x between -3 and +3. And we are going to do a graph in a minute. Now, we're going to do this through a table. Now, normally, most graphs you deal with are starting y equals something. This isn't. It's got squareds in as well. So we're going to have a table. It will fit across the width of the page. We're going to have an x row to our table, then an x squared row to our table, then a y squared row to our table, then a y row to our table, and then a coordinates row to our table. So if you're the person who really likes neat tables with nice straight lines, now's the time to grab your ruler. Okay, I haven't got my quickie to hand in this room. So, we are going to start off with this table looking at what happens when x is 0. Okay, when x is 0, what is x squared equal to? 0. Now, the equation we're looking at is this equation up here. Let's put that in a red box to make that equation stand out a minute. Now, if x squared plus y squared has to equal 9, and we've just worked out x squared equals 0, what has y squared got to be? 9. Okay? Because up here it says x squared plus y squared's got to equal 9. And if x squared is 0, y squared's got to equal 9. So if y squared equals 9, what would y be? 3 or minus 3. Yeah, don't forget that plus or minus 3. I think my blue's running out. I'll change colour. Plus or minus 3. So, coordinates are always x, y pairs. What coordinates are we going to get here? Well, x can be 0 and y could be minus 3. Or x could be 0 and y could be 3. So we get two coordinates from that starting point. Are we all okay in seeing what's happened there? Okay. So the next thing we're going to consider is x being 1. If x is 1, what is x squared?
1.
So what will y squared have to be? 8. So what will y have to be? Plus or minus the square root of 8. Now, because we're going to graph this, what is the square root of 8 to one decimal place? We have someone over here doing it in their head or coming up with something. You've all got calculators. You're allowed to press the buttons on the calculator. I don't expect you to do this in your head. Go on. 2.8. Okay, so we'll call this here plus or minus 2.8, because if we're going to graph it, that would be far more useful. So here, the coordinates we've got is when x is 1, we can have a minus 2.8 for y, or when x is 1, we can have a positive 2.8 for y. But are there any other coordinates you think we could probably get out of maybe an adapted column here? Is there another value that would have given us an x squared value of 1? Yeah, actually I could put here or minus 1, because if I started with minus 1, I'd have also got identical things further down that column. So actually down here I could have minus 1 minus 2.8, and I could have minus 1 2.8. So I've got 4 coordinates there from that column. Can you now do a similar thing for when x is 2 and for when x is 3? Okay, I'm not going to talk them through. I'll put them up here in a minute. I'll just freeze it for you in the classroom. If you're watching on video, well, you'll see it anyway. Yeah, just if you're going to graph it, just round it to one decimal place. You're never going to graph it more accurately than that. I reckon when you have completed the table, you should have 12 coordinates. and no number in any of those coordinates is greater than 3 or less than -3. So if you draw on the graph paper, you've got a set of axes going from -3 to 3 in the x direction, -3 to 3 in the y direction, and use the big squares for every one. And because we've done the point numbers, you can find that on the square on the graph paper quite easily. If we can then graph that and join all of those 12 points, the video will continue in a minute. So you're graphing all the 12 coordinates you should have. Okay.